Welcome to another episode of Software Explorations, Concept and Overviews, hosted by yours truly, Tech Coach Ralph. In today's episode, we are going to be going over unit testing. So if you're not familiar with unit testing, it is a software development technique where we attempt to test the smallest unit of code to make sure that all components of the software are working correctly on an individual basis. So let's get into it. First, if you haven't done so yet, subscribe to the channel, hit the notification bell so you can know every time that we go live. And when we release new content, like the video and share the video with somebody who will find it useful. And of course, check out the Patreon to see all the amazing content that is left off of YouTube because it is very exclusive to help you land your next position and level up your career. But let's get straight into unit testing now. All right, so here I am right here in the top right corner. So like I said, our topic is unit testing. So let's go over our agenda for today. We're going to be covering what is unit testing, the actual goal of unit testing, a unit testing strategy, the key characteristics of unit testing, and then the key components of unit testing. Then we're going to go over pretty much structuring our unit tests, the benefits of unit testing, the drawbacks and the challenges, and the methods that we can execute, that we can create unit tests, and then the unit tests in the software development lifecycle. So let's jump into it. So what the heck is a unit test anyways? A unit test is a software testing technique used in software development to evaluate individual units or components of a software application in isolation. So we're pretty much taking the different parts of the software to its very smallest piece, and then we're testing that small piece to make sure that piece on its own is working before we actually start to integrate it with other parts of the software. A unit in this context refers to the smallest testable part of the software, typically a single function, method, or class. And what's the goal? What's the purpose of the unit test? The primary goal of unit testing is to ensure that each unit of code performs as expected and functions correctly in isolation from the rest of the program. So before we start mixing and matching different parts of the software, different parts of the code, one method here working with this method here, we have to make sure each individual part of the software is working properly. Before we go and we mix and match, we have to make sure on its own it's working as expected. So what is the basic unit testing strategy, right? It breaks down like this. It's arrange, act, and assert, right? So arrange, it covers the inputs and the targets. It pretty much sets up the test case. It's the preconditions, right? What do you need to have the test case execute properly, right? And we'll cover that later in the example. Okay. Then we have act. It covers the main action to be tested. So pretty much what the actual function or method is actually doing. That's what the act part covers. And then assert. It covers the expected outcomes. It elicits some type of response, right? So in every unit test, you should have an expected result. And then you also have an actual result, and you compare the expected results to the actual result. That's what you are asserting. So what are the key characteristics of a unit test? So a unit test should be able to be ran in isolation. It's, without saying, it should be automated. It should be repeatable. So that means like it's not only one time that you run it and then you can't ever run it again. You should be able to run it a trillion times without any issues. They should also be fast, very, very fast, because the proper strategy for running unit tests is like after every few lines of code that you run, you should be able to run your unit tests and they should still be passing. So you can't be waiting minutes or even many seconds for them to run, right? They should be comprehensive. They should cover pretty much all aspects of your tests, and they should be like the most tests that you have, because when it's comprehensive, you would like you can have a method that has, let's say you have one method, it can have 10 different unit tests to make sure that that method is working, under pressure, like under many different types of data being inputted. um, it should work, right? It should be maintainable as well. So by maintainable, that means just because you make a change in one spot of the code, it shouldn't be breaking your unit test in another part of the code. If that's happening, then your tests aren't isolated, and that makes it not non-maintainable. They should also be independent, just like they're isolated, right? You should be able to run one unit test. Let's say you have 1,000. You should be able to run one unit test, and that one unit test should still be able to pass. And your unit test should have assertions. So every unit test should be verifying something. Pretty much assertions are, verification. Anytime you run a unit test, you should have what you expect to happen and what actually happens, and those should match. So here are a list of key components for a unit test. We're not going to get in depth into all of them, but I just want to touch on them on a high level because they are very important. Okay, so the key components, right? There's test cases, there's text fixtures, right? So the test case is what's actually going to be under test. The test fixtures are the what you need to set up for your test, like setting up the data and everything like that. And there's assertions that we already spoke about, but that's the, verifying that the tests meet their expected results based off the actual results, right? So then there's test doubles. Test doubles are how you would mock different components that the test might need so that you don't actually have to call that component into the unit test because we want to keep the unit test isolated, independent, maintainable, right? Then we have our test runner. So the test framework is what is all the components of what's able to execute your test, right? So in different languages, there's different frameworks. For example, and we'll cover this in a little bit, but in Java, you might be using JUnit, you might be using test and G. And in addition to that, you can also create your own test framework based on existing frameworks, right? And then we have setup and teardown. So where you set up your unit test and, like where prior to the unit test being executed, you might need some certain data to be staged. And then after your unit test run, you might also need certain things to be torn down. So for example, if you're adding stuff to a database, which is probably a better strategy to do that, or if you are spinning up a database on the fly for your unit test, you can also in the setup and in the teardown, you can also get rid of that database, right? Then there's test coverage. Test coverage is important because it lets you know how much of your code is actually covered. So some people they will, they're not too keen on the test coverage number, but to me, it's better to have a good amount of coverage good with good unit tests than not to have any test coverage and bad unit tests, right? I think the two kind of go hand in hand. When we try to isolate um, these components of unit testing, then that's when we lead to disaster. So we should have good test coverage, but we should also have good test cases for our unit tests, right? Then very important, we have naming conventions. I'm very particular about naming conventions because I think naming your test and your methods and all that stuff should be very descriptive. I don't like to be, trying to figure out like even why I name something that way or what something that I name means. I like to be very clear and writing out my method names, even if they can be very long, right? And think about it like this: with the help of IDEs, you don't have to remember everything you named because once you start typing, the predictive text will give you the rest, right? So I'm a fan of having very long naming conventions, in the proper like formatted properties of the languages you're writing in, and then I know exactly what the variable or the method or the class that I'm working in, exactly what it does, right? Okay, so another component is test suites. And with the test suites, you can group your unit tests based on what they're covering. So for example, if you're working on one part of the software, you can say, all right, run this test suite because it doesn't affect the other part of the software. And the way that can happen is like, so you're working on one part of the software, right? You run the test suite over and over and over as you're developing and you're making sure that passes. And then you can go and run the full unit, the full suite or all the unit tests. And then you can get some feedback from there. So it just depends on how you use your test suites. But at the same time, your unit tests, as part of the characteristics, your unit test should run very fast, right? So you might not even need test suites for running your unit test. It just depends, right? It just depends. So it's all about structuring your unit test. Then we have an assertion library where with the assertion library, to me, what that would mean is you have different types of assertions that you can run. And sometimes, like what I've done with assertions is I've customized my assertions so I can choose, like if I'm asserting some type of number or if I'm asserting some type of range, something that includes something. So to me, that's what the assertion library would be. And then, of course, there's the test data. How do you handle your test data for your unit test? So, and to me, the test data part might be one of the most important parts. Based on the type of testing that you're doing, it might be a little bit different going from unit testing to functional testing, component testing, automated testing. But test data across all types of testing is very, very important. So now, how do we structure our unit tests, right? So going back to the principles of arrange, act, and assert, right? We're going to have our test fixture set up. So that's how we arrange our test. So for example, with a test fixture, we'll see in another example, but it would be, all right, this is the test data that I'm going to use for my unit test, right? So that's the arrange. And now let's say our test execution, let's say we have a method that's supposed to be subtracting numbers, right? So let's say we have D minus C. So our the act part, the test execution part would be the method that's doing D minus C. And the assertion would be, all right, once I pass, let's say in my arrange, I have 10 and 5, right? 10 for D, 5 for C, right? So my assertion would be when I execute the method, the subtraction method, right? Passing in the variables of D and C, then I should assert that um, when I run that subtraction method, right? That it will equal to what 10 minus 5 is, which would be 5, right? So that's where the assertion comes in. So we have our test fixture where we're setting up our test data, which is 10 and 5. Our test execution where we're running the method of subtract, right? We're passing those two variables, the two parameters, and then the assertion is what is the end result, right? I'm comparing the method result to my expected result. Okay. All right. What are some unit testing frameworks? So I just listed a few. There are a lot more, right? But in Java, for instance, there's JUnit, there's TestNG. From what I've seen, developers tend to fancy JUnit, and QA automation tends to fancy TestNG. They can work intertwined. Like you can not intertwined, but like developers can definitely use TestNG, and QA can definitely use JUnit. It just a matter. Like I think JUnit has been around for so long that developers are comfortable with it. But they are very very similar from what I've seen. I like TestNG because it adds a little bit more options for what I do with automated testing. But I've seen that JUnit has made some great strides to get closer to TestNG, so that's also interesting. In .NET framework, there is NUnit, right? Which it's similar to JUnit, but it's for the .NET framework. And then in JavaScript, there's a few, but one that is most popular, I would say, is Jest. And then in Python, there's also a few. Like you don't even like there's pytest, right? But you don't even need pytest. You can use straight up the unit test. Um, you can use a straight up unit test library to do unit testing in Python. But a very popular one in Python is pytest, which I actually like to use. All right. So what are the benefits of unit testing? To me, one of the biggest benefits is that it helps catch bugs early, right? Um, you get so much instant feedback from having good comprehensive unit tests that whenever you make a little change, you can run your unit tests, and then if they fail, then you have to go back and figure out what's going on. And it has the ability to run many tests very, very quickly. One of the problems that we have with automated testing, especially on the UI base, is that they can run very slow because you have to go open up a browser, navigate to a whole bunch of stuff. With the unit test, you are testing at the smallest level of code, and with proper unit tests, you can catch many issues before you even push them to be tested by QA. Right? A developer can catch many of their issues by having properly structured unit tests. And in addition, if done correctly, unit tests help keep your code clean, right? One of my favorite books, is Clean Code. by Robert C. Martin, and also The Clean Coder by Robert C. Martin. And I believe that writing, like keeping your code clean, is going to make you it's gonna be beneficial to you in the long run, right? A lot of times we are like, oh, it takes too long to write unit tests and to keep them clean. But trust me, down the line, it's going to cost you way more by not having written a clean written development code and clean written unit test, right? So, what are the drawbacks and the challenges? So, in actuality, some of the key characteristics are also the challenges. Like trying to keep your unit test isolated, that's a challenge. Trying to keep it maintainable, that's a challenge, right? Good unit tests follow those key characteristics. Bad unit tests have trouble meeting those characteristics. Another very, very challenging part of unit tests is adding unit tests to legacy code, especially legacy code that doesn't have any unit tests, so you're trying to figure it out. One of the suggestions I've heard to adding unit tests to legacy code is whenever you have to go make a change in that legacy code, write a unit test for that change first, right? And then make the change and make sure that unit test is still passing. It's really hard to add unit tests to legacy code because a lot of times we don't really know what it does and we don't want to touch it. But when you have to touch it, show it some love and add unit tests around it. And like I said earlier, keeping the test isolated and independent, very, very hard because it's so tempting, right? It's so tempting to like, oh, I just need to call this one method into this unit test and it'll be done. However, the problem with that is if that other method has to change, then like your tests are no longer isolated, they're no longer independent, they're no longer maintainable because now you make a change in this one test and now you have to go to this, like you have to go to a series of tests that are calling it to make changes there as well. So that's the comes in the purpose of those test doubles where you're doing mocks, you're doing whatever. Like I don't even recall the names of them exactly, right? But you need to find a way to not have your tests rely on each other. So whether you're mocking different database stuff or staging some type of data in one way, you just need to keep your tests isolated and independent so they don't end up falling on top of each other. And now everything is a big spaghetti mess pasta. So what are the methods of unit testing, right? So I think the most traditional method would be writing your unit test after the code is written. So you write some code and then you write your unit test and make sure that the code is working, right? To me, that is not the most beneficial way to do it. I personally prefer using test-driven development or behavior-driven development. So test-driven development is you write your test first and you get your test to fail, and then you write your code that's going to then make your test pass, right? And then once you do that, like so, it's like you write your test, right? And I'll explain it in our example, but you write your test and your test actually fail because there's no actual code, right? So as your test fail, you're running it constantly, right? As your test fails, then you write the code to get the test passed. So now you write a little bit more to the test, right? And as it continues to fail, you continue to write code to get it to pass. But at the end of the day, right? So if you have, let's say we take back that subtraction example, 10 minus 5. So let's say eventually you say, all right, you have your tests, you have your range, your test fixture where you say your two values are 10 and 5. And then you do a subtraction method and you do the assert, right? Which would be 10 and 5, 10 minus 5. So now you don't have the code. You don't have so you might have the method created for subtract, right? But you don't have the actual code to do the subtraction. So now your test is going to fail. But once you actually add the code for, D minus C, then once you run it, now it should start to pass, right? And that's the concept. That's a very, very, very high level concept of test-driven development. But it does help you keep the code clean. And then after you do that, now once you have your test passing, now you can go in and refactor your code. And every time you refactor, all you have to do is run your test. And if it fails, then you know that you've broken something and you have to go back and fix it, right? before you move forward. You have to go back and fix it. So you don't want to get too far away from the changes that you made before you actually run it. You should be running it constantly, right? And then we have the concept of behavior-driven development. So this one is a little interesting, right? Because when I first learned about BDD, it's a actual development style. It says in the name, behavior-driven development. But the tools that you'd use for, like, from what I'm seeing lately, I'm seeing that they're suggesting that you don't use BDD to like for unit testing, right? But this is the way that it was originally presented to me. You have your features written in human readable form. So given that this is the preconditions, when I do this, then that should happen, right? So I'm just giving a very high level of how it's worded, okay? And then it would actually generate the code for you. And based on, when I say the code, it would generate the methods that you need for your given, for your when, and for your then. And when you would actually go and you fill out the methods, those should be meeting the conditions of the test, right? So it's actually kind of possible to do unit testing with BDD, although I think we've strayed away from how, like, the original intentions of it, but we might have to revisit that one day. Maybe I'll do a video about behavior-driven development so we can revisit that. But at the time when I first learned about it, it did seem like a novel concept, but like I said, we'll definitely revisit that. All right, so unit tests in the software development lifecycle. So typically developers have written unit tests. I think that QA could contribute to it, but it's also my belief that the best way to write unit tests is to write them before you actually write your code. So maybe right. I have like different thoughts about this, but if QA were to help contribute to a unit test, they would have to write it before the developers start to code, and they would have to, and I don't know. I'm still hashing that out, right? But I think that QA does have a role where they can be involved in the unit test, even if they're suggesting to developers, this is what we would test. This is what we're going to test. So maybe you can take into consideration some of your unit tests based on what we would test. I don't know. That I'm still processing that in my mind, right? But typically developers have written unit tests and they would run it locally on their branch before they push it to the CI/CD pipeline. Once it's passing locally, right? Then they're going to push it up to the CI/CD, and the build tool should also be verifying that the unit tests are passing on the build. And once that's done, and it's QA tested and everything like that, and we get the green light to merge into main or master branch, then the unit tests also run on the main or master branch to make sure that the merge did not affect our unit test. And if it does, then we definitely have to roll back to the previous version of main or master, and we need to check what's going on when we're merging, when we're merging, and what's causing our unit test to fail. All right, so let's go over a simple unit test, right? So we're going to go over this in two ways. We're going to go over this in the TDD way and the traditional way. So right now, on the left side, we have our dev code. So we have a multiply function. We say multiply, and we pass the parameters A and B. And the results equals A times B. And then we're going to return the results, right? The result, which is A times B. Now, in our left side, we have our unit test, right? So we're saying our test fixture, the arrange part, is A equals 2, B equals 3. Our act part is where we are executing we're testing our function multiply. We're saying result equals multiply, and then we're passing the parameters from the arrange A and B, right? And the assertion is results should equal 6. So when you do the multiply, it's going to pass in the parameters of A and B, right? And it's going to call the development code of multiply, and our assert should say results should equal the result of multiply function, which is passing 2 and 6, which should be 6 and 6, right? So like I was saying so now that's our unit test. But if we're approaching it from a TDD standpoint, let's say we write our test. So we don't have our dev code yet, right? We just have our test underscore multiply, and we have our test fixture, still same thing, right? A A and B, 2 and 3, right? And now we have our act saying result equals multiply A and B. So right now, at this point, if you try to run it, the test would fail because the multiply function doesn't exist. So so now let's say we create the dev code for multiply, right? And all it has is multiply and it takes A and B. So now our code is going to pass. So now when we do assert and we do assert equals results, and so the result should equal to 6. When you run it, it's going to fail, right? So it's going to fail because you don't have any code as part of your multiply function. So now you're going to add the result equals A times B, and it's going to return the result. So now when you run your test, it should be passing because they should be equal together. And like I said, you can have multiple, you see, if you look at this, right? We have, looking at here, we have our dev code, we have 3 lines of code, right? For our dev code, our unit test has 1, 2, 3, 4 lines of code. Right, so you generally have, or let's say 1, 2, 3, 4, 5 lines of code to our 3 lines of code over here. Okay, so what that typically means is that you're going to have a lot more code for your unit test than you are going to have for your development test. But it's very important because one slight mistake in your testing can cause to one slight mistake in your dev code, which could cause to massive issues, right? So then in the same breath, we can have another unit test where we're passing different data, right? And that data should still equal, like we should still get the right results, you know? And then you can have another unit test where you're passing, let's say you try to pass a character, right? So now you're not going to be able to multiply a character, but you should be asserting that you get some type of particular error. And so you can have like 10, 20, 30 unit tests for one little piece of dev code, right? And that's the importance of properly testing your software and starting from the smallest level, which is a unit test. All right. So in conclusion, right, we know that unit tests can be challenging to write, but they are extremely important. We should, like, our primary focus should be on producing useful unit tests. We're not just writing unit tests to say that we have unit tests or to try to boost our coverage numbers. No, we should be writing unit tests that are producing useful. We should be writing unit tests that are useful, right? And they should still be increasing our code coverage, but they should also be useful. Okay, we should organize our unit tests based on the AAA principles: arrange, act, and assert. And I would encourage you to try out BDD and TDD to enhance our unit tests. Keep in mind the key characteristics that can be our greatest challenges. Keep in mind the key characteristics can also be our greatest challenges and drawbacks as well. So we need to properly structure our unit tests so that those key characteristics work to our benefit and not to our disadvantage. All right. So that is our presentation on unit testing. I hope you found that useful. Like I said, from my experience, unit tests can be controversial based on the developer. Some developers, they live by unit tests. They find it extremely important. And then some other developers are like, they're not important. They're like, it's so. But I believe that, to me, I think unit tests are the foundation of having good software, because we have something that we can always run to have some level of confidence. It's not the end all be all, but it's a part of it. It's a tool. And to me, part of the testing pyramid starts with unit testing, right? And then that's the biggest base, that's the foundation. And I believe that if we can have good unit test coverage with with unit tests that are written properly, that have a good coverage and good data that's being passed, just a very thoughtful unit test, then that goes into simplifying all other parts of the software development lifecycle, and it allows us to produce amazing software. So that's our presentation for today. Thank you for following along. If you're new to the channel, please hit the subscribe button, hit the notification bell so you can know that every time that we go live. Like the video, share the video, and of course, check out the Patreon. Like I said, there is tons and tons of amazing content in there that I've created just for people like you. And I know that you want to take your career to the next level. So don't hesitate. Give it a try. Give it a look, and you'll see that it adds great value to your life. But on that note, everyone, this has been another episode of Software Explorations. This is Tech Coach Ralph signing off.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.